Afternoon, everyone, or good morning or good evening, wherever you are. Thank you very much for joining this webinar on the Wikio Jupyter Notebook Competition. Today we will be speaking about what the competition entails, what the Wikio Dias is, and how to best use it so that you can build your Jupyter Notebook on the Wikio platform, as well as some of the key Copernicus data and products that you can use to build your Jupyter Notebook and build a winning algorithm. So on the Copernicus Land Monitoring Service, we have the European Environment Agency speaking today. On the Copernicus Marine Environment Monitoring Service, we have Mercator Océan International speaking, and then ECMWF will also speak about the air quality monitoring service and the climate change service of Copernicus. So without further ado, I would like to introduce Neil Fletcher from EUMETSAT to explain a little bit about the Jupyter Notebook Competition.
Okay, thanks a lot, Anna-Katrina, that's great. Hi everyone, thanks for joining us for this webinar today about the notebook competition. It's really good to see so many people here. So I just want to give you a kind of recap about the competition, what it's all about and what we're trying to achieve. So basically, the idea behind the competition is that we want people to submit Jupyter notebooks, Python-based Jupyter notebooks that work with Copernicus data. And when I say work with Copernicus data, I mean maybe showing people how to access it and work with different data sets, or how to visualize Copernicus data, or tell stories with the Jupyter notebook, or even using machine learning techniques with the notebook. And the idea behind this is that we know that sometimes people struggle to work initially with Copernicus Earth observation data to begin with. And also they're often Jupyter notebooks, but they're often in different places, and it's hard to find them, or to get the notebooks that you might find most helpful. So what we're trying to do with this competition really is to kind of build up a community-driven library of notebooks that will be available for people to come and access them and inspire them and get some really good ideas about how you could work with Copernicus data. And we want you to use the Copernicus Vecchio platform, which is an online data access platform to all of the Copernicus data sets. And on there, so you'll be able to, with your notebook, you can access data from air quality to oceans, a whole range of different data sets. And there's a Jupyter Lab environment once you've registered, where you can actually go and work and test your notebook and kind of develop something really innovative and that other people can learn from. So we go to the next slide. Yeah. So why enter the competition? Well, we think there's a lot of really cool opportunities with this competition, really. The first thing is it kind of opens up the opportunity to learn about all the different data sets, the different Copernicus Earth observation data sets, and find out about them. And some of my colleagues from our partner organizations are going to be talking about these data sets and really what you can actually do with them, and hopefully giving you some good ideas. The other point is that the ideas that you create in your notebook, we want them to help other people to develop their own work and develop notebooks. So your work could really help to inspire and help people really to make more of Copernicus data, so we can learn more about the Earth and the atmosphere and the oceans. The third thing is obviously there's cash prizes. We've got a cash pool of €5,000 for the best notebooks. And then finally, I think it's an opportunity really for people to do innovative things with Copernicus data, and also to kind of highlight your experience to the wider community. So can we get the next slide, please? So if you want to enter the competition, the actual process is outlined here. You can enter now. There's basically, we have the landing page where you can go, and from there you can register on the actual competition platform. And the benefit of that is that then you're registered on our system, and then also you get updates about the competition as we go along. The next thing you need to do is to choose the type of notebook that you want to develop, the track and the thematic data that you want to use. So I'll talk about that in the next slide. After you've chosen the kind of notebook you want to develop, the topic you want to cover, and the type, whether it's visualizing or maybe machine learning, that kind of thing, you then can register for the Vecchio platform. And once you've registered, you can have a look at the environment there and start to discover some of the Copernicus data that you'll have heard a little bit more about today by some of my colleagues. And then when you've started working on Vecchio in the Jupyter Lab, you can then actually start to develop your notebook, and then you just need to submit that notebook before the end of the competition, which is the 31st of July. And then after that, we'll have a judging process, and then we'll have a kind of final seminar in September, where we'll highlight the best notebooks, but we'll keep you informed about that. We have the next slide. So just to say a few words about the tracks, there's a lot more information that you can look at on the landing page, but the main tracks are really in terms of how the type of notebook and things you want to cover. The first one is really do a notebook that shows people how to access and work with Copernicus data, really to sort of help people get started. And it could be using ocean, atmosphere, land, or climate data, or combining the data in different ways, in kind of new and innovative ways. So that would be track one. And another track would be to develop a notebook that really helps people to visualize changes to our environment. So it could be looking at atmosphere data or ocean data. And we'd be looking for really kind of innovative ways of showing and kind of helping people see what's actually happening in the environment by using Copernicus data or service data. The track C is to look at machine learning, and maybe you could come up with a really cool notebook that uses machine learning in new ways with Earth observation data, new ways that then people could follow and perhaps come up with their own different takes on how we could really use machine learning with Copernicus data. We've actually recently run a MOOC on AI and Earth monitoring, which is available, and we can provide a link to that, which might also give you some inspiration for some of the other things that people are doing with Copernicus data and machine learning. And then the final track is really about bringing awareness of challenges on planet Earth, to really kind of tell a story with the notebook that people can follow, maybe people who are kind of fairly new to coding, even just to give them an idea of what you can do and how you can work with different types of Copernicus data to tell a really strong story that really has an impact on people and catches their interest. Okay, can we go to the next slide, please? Okay. Yeah, I was just going to say one final thing, really, that there's a huge amount of data there, and we really want to see some great notebooks and some innovation that will really kickstart other people to start their journeys working with Copernicus data. So good luck, and we've got a great lineup of speakers for you here. So I'll pass you back to Anna-Katrine.
Thank you, Neil. So as Neil mentioned, we want to have this whole library of Wikio Jupyter notebooks. But how do you get started? That's what Haley Everett-King from UMatsat is going to explain to you in the next slides.
Thanks very much, Anne-Katrine. Hopefully everybody can hear me. Hi, my name is Haley. I work here at UMatsat as one of our user support experts. My particular field of interest is the marine domain, and particularly our Sentinel-3 and 6 satellites that are flown under the Copernicus program. I've been involved in lots of different Wekio activities, including writing some of the notebooks that you'll see already on our platform. And I really can't wait to see what you all come up with during the course of the competition. So today I'm just going to give you a little bit of a background to the platform. There's many more resources available about the platform on our website and on our YouTube page, and I'll point to some other resources during the course of this presentation, but hopefully this will be enough to get you started. So a bit of an introduction to Wekio for those of you that are new to the system and have never used it. Wekio is one of the Copernicus DAS systems, a system that combines data access and computing resources, as well as user support and expertise to help you to access the vast array of data that's available in the Copernicus program. And we Wekio itself is a platform that is run as a project by a combination of different entities who you see represented here today amongst myself and my colleagues. So as I said, it's under the Copernicus program, but behind the scenes, there's Mercator Ocean International, ECMWF, us at EUMETSAT, and our colleagues at the European Environment Agency, who are, if you know much about the Copernicus program, some of the key entities that are involved in both operating the satellites and producing the data, as well as operating the Copernicus services, which produce further downstream data using the satellite data and models. So Wekio is really embedded quite deeply into the Copernicus ecosystem, and it benefits a lot from the support of these different entities in terms of our expertise in the data. And really, you couldn't get closer to the data than being within this ecosystem. So one thing that Wekio does offer is a single access point to a large portion, I think the largest proportion amongst the DSs of the Copernicus data. So this includes the data from the satellites, Sentinels, as well as the data from the different services you can see on the right-hand side of the slide there. And you can access this data both through a viewer and through at the back end a harmonized data access API. And this is quite powerful for when you're wanting to work in a programmatic environment, such as with the Jupyter notebooks. The data is federated across the different entities, so we can pretty much guarantee that what we are giving you is the data that is we recommend as the highest quality, and you won't be getting a data that is a copy. It's data that is directly from the suppliers, as it were. Alongside, oh, sorry, not finished yet. Thank you. Alongside the data access, we have cloud-based hosted processing tools, one of which is the Jupyter Lab, which we'll see in a minute. We also have virtual machines, which you can access in both free trial and paid formats. And then the last part is we have what we consider a very strong and enthusiastic and expert user support team, of which everybody here is a part. So you can really ask questions about all sorts of things from the system itself, all the way through the data and the different application domains, and we'd be very happy to help you. Okay, next slide, please. So to get started, I've said that there are three really key things I think you need to know to participate in our notebook competition. The first thing is to know about the data viewer, so you can explore the data offer through this. You can look at the catalogue and you can get a quick view of some of the products that are available there, and you can start playing with downloading the data. And this really is your entry point then into learning about the Harmonized Data Access and its API. The Wekio Data Viewer sits kind of on top of this, and it actually accesses it if you make a request for data, and you can use the viewer to generate an API request, which you can then incorporate programmatically into notebooks, as well as into other programming languages as you wish if you're more advanced as a user. So the last point there is accessing the Jupyter Lab. So this is kind of key to the competition. We'd like to see eventually we'd like to see your notebooks available and running in our Jupyter Lab so that other people can explore the data as you have done. And we have various example notebooks in there from our training events and other things that we've done so far, including our Massive Open Online course. So I will show you these things now. Next slide, please. As I said, the first thing to look at is the data viewer, and this is really where you can explore. So this is about searching and downloading the Copernicus data. You can see a little screenshot of it on the right, but I'll show you more what it looks like in a minute. Next slide, please. Behind the scenes is the Wekio HDA, the Harmonized Data Access. So this is an API, and we have also provided a client access the API to allow you to programmatically access the data. This means you can access from a notebook or from the command line, running different commands as well. You can see just an example there of what an API request to the Harmonized Data Access API looks like, and you can generate these from the viewer, as I mentioned. Next slide, please. And then this will bring us to the Jupyter Lab. So there's a little screenshot here of what the Jupyter Lab can look like, and I'll show it you now. If I can just steal the screenshot of you, Anne-Catherine, that would be good. Thank you. Okay. Can you now see my screen?
Yep.
Okay. So what you should see here then is the Wekio website. So if you haven't already, you can visit the platform here and register. If you click sign in, as I will do now, it will prompt you to register if you haven't, but for me, I already have an account, so I can sign in. And I just wanted to point out a few things on here. So first of all, if you click on data, this takes you to the data viewer. And you can see here, this is not actually the default you would see when you sign in. This is actually where I was when I was working on the data viewer earlier. And this is one of my favorite products. So you can see this is already loaded that, but you can click on the plus sign here and you can explore the various different data sets that are available through Wekio and from Copernicus as a whole. You can search using free text. Otherwise, they're organized under the different services, satellite platforms, sensors, in fact, as well. Regional areas and time, as well as through a variety of different application-based tags. So if you search through here, you can find various different types of data depending on what sort of environmental parameter or phenomena you're interested in. And if you want to add them to them, if you want to then look at them in more detail, you can click add them to map and they will pop up in your layers over here. But let's go back and look at the Ulchi one that I already had preloaded. You can look at the information here. It tells you about the data. There's resources where you can find out more information, and it tells you where it's come from as well. It tells you its temporal extent and its latitudinal extent. This is quite useful depending on the type of application you're interested in. And if you go here then and click on the download button, you can start looking at accessing this data. Now you can set a region of interest using the viewer. So if I click on the AOI button on the right, I can then copy this in, so I can search for specific data relating to this area. I can also choose where in the time period that I'm interested in using this. For the satellite data, there's often various other parameters that you can select. So in the case of the Sentinel-3 data, you have some options, for example, for timeliness. You have orbit direction. This is quite useful if you're looking at the sea surface temperature data instead of the ocean color. It's only on one pass, so this actually doesn't, you can't make a choice here, but for the sea surface temperature you can. Or you can search if you know specifically by orbit numbers and relative orbit numbers. So if you do know you're looking for a very specific piece of data, you can do this. If you look at other products, you'll see different search criteria here. There's a different parameter selection here. If it's a model, you might see information over depth as well. And some products have multiple subparameters in them. So you'll see different search options here depending on what you select. If you then click show API request, this is where we start getting into how we access the data programmatically. This will give you the query here, and you can save this and use it in your programming approaches later on. So when I show you the Jupyter Notebooks in a minute, you'll see that this is basically what we've used to get the Jupyter Notebooks to access the particular data that we're interested in. So you can copy this out of here. So it's quite nice. If you're not that familiar with using APIs and programming, this gives you kind of a soft landing into getting into the data. So I think that covers most of how the viewer works. If I now go back to the main web page, I can show you the dashboard, and this is then where you can access Jupyter environment. So you'll see here on the left, there is the Jupyter Hub. It's actually a Jupyter Lab environment. If you know Jupyter, you'll know that there's a slight difference between them, but they both effectively are these interactive hosted processing environments where you can run Jupyter Notebooks. So if you click on this, it will load up. I've already loaded it myself. This is what it looks like when it loads. When you click, you'll get two options. One is for an Earth observation version and one is for a machine learning version. You can use either. They're spec'd slightly differently. One was maybe more for using our AI for EO MOOC material, and one is more for general EO purposes. But you can probably use either depending on your subject of interest. They show up quite similarly and have similar specifications. When you enter the environment here, if you're not familiar with Jupyter Lab, you have the launcher. From here, you can open notebooks, you can open a terminal. You can see I've actually set up some of my own environments in here. So if you set up an environment, if you're familiar with Jupyter, it'll pop up here too. You can open text files and things like that, which are quite useful to know as well. Within our Jupyter Lab on Webio, you have a public folder, and in here you can see some example notebooks that we've already sort of preloaded and shared of key interest for you. If you're new to using Webio in the HDA, it's probably the Webio for Data folder. Within here, there is a notebook, which I've actually already got opened over here, which will show you how to use the Harmonized Data Access API, walk you through it step by step. You can have a look through this in your own time and feel free to ask us questions through the user support. But in short, it will show you how to open the client that we have provided for working with the HDA API. It'll tell you a little bit about how you generate the queries, and it will also show you how to configure your authentication, which you'll need your username and password for. This is something that requires a little bit of attention. So if you do get stuck, get in touch with our help desk and we can help you make sure you're configured correctly to access the data. Within the public folder, there's also some other notebooks around different thematics. My colleagues will talk more about the actual data later, but you can go through these and look for some examples of inspiration for you. Just showing you some of ours here. This is one of mine that I used in another webinar we ran for Webio this morning. If it loads, you might want to use these to have a little bit of a look at how we've set up our notebooks. There's lots of ways you can write notebooks, but we've tried to write these in a way that's suitable for helping other people to understand the data. So maybe there's something there that's useful for you, but we're also very keen to learn from how you do things to improve the way we write our notebooks as well. So I'm very much looking forward to seeing how you approach writing your notebooks. A few more bits to note. If you want to work with the code from the public folder, you'll need to copy it into your working directory. You can also pull it down from our Git repository. This is here, github.com/Webio. All these code repositories are in here, so you can also clone them in, and indeed you can clone from any other repository that you want to bring in as well. I think that's it for my demo. Anne-Catherine, could you bring the slides back up, please? Okay, so just to summarize before I finish, some little technical hints and tips. So I really recommend you use the data viewer to help you get started with building the API queries and finding the sort of data that you need. You can check out the example notebooks, particularly for the examples of using the HDA and its client. There's also information within those notebooks about the various data files. So if you're not familiar with using Copernicus data, there's a lot of sort of helpful information explaining the file structure and how you access them there. You can copy the notebooks from public into your own working space or clone from the Webio GitLab. Don't forget to set your credentials to the HDA client. This can be a little tricky, so we're happy to help you with that. Feel free to create your own Python environment if you'd like to install and use other libraries, but we'd really like you to make a note of these so that we know what you've used to create the notebook so we can run them later ourselves, and also carefully consider how you might license this. We want to try and make our notebooks shareable with everybody, so licensing is quite important. So maybe don't use anything that's protected with a restricted license. You can get extra guidance on all these different aspects of using the system through our YouTube videos. All our training webinars and things are on there. We've also produced various other guiding videos, and through the website and through the user support services, lots of technical information that we can provide you with as well. Next slide, please. Okay, so what do you do next? Go and discover the data. Please explore the vast array that's available through the viewer, and do ask us as experts if there's anything we can help you with to explain the data and potential applications. Try out the Jupyter Lab, maybe get started with some of the notebooks that are already on there if you're still learning a bit about how to use Python. I fully expect that many of you are better coders than me, so I'd really welcome any feedback on some of the notebooks that are on there already. Please develop your own notebooks then and submit to the competition. We'd love for you to tell a story with the data you've chosen, share why it's useful, how it can be visualized and analyzed, and then submit your idea. We can't wait to see what you come up with. That's all from me. Thank you very much. I look forward to answering your questions.
Thank you, Haley. Indeed, there have been already a few questions in the chat and in the Q&A, but some of these questions I think might have already been answered throughout the presentation. So we'll wait for the Q&A to answer any remaining questions until the end of the webinar, but please keep putting them in the chat or in the Q&A. So next up, we will learn more about the Copernicus data and the key products that you could be using. We're starting with the Copernicus Land Monitoring Service. And Joanna, I'm not going to pronounce your last name, from the European Environment Agency is going to present us the Copernicus Land Monitoring Service. Joanna, the floor is yours.
Thank you. Yes, thank you, Anna-Katrina. Hello, everyone. I'm Joanna Przystawska, really difficult one, and I work at the European Environment Agency in the Copernicus program. So today I would like to introduce you to the Copernicus land monitoring products that are hosted on WikiODS. The Copernicus products that you can work with are pan-European high-resolution biophysical parameters. Among them, we have phenology and productivity products and snow and ice products. And I will not go into details regarding the data access. You can find information on the Copernicus Land portal, and this is actually our website that I would direct you to use with regards to data access, but also if you have any questions, we have Copernicus help desk that we are happy to answer your questions. So to navigate to the data access, you need to go to Pan-European and then choose biophysical parameters and then choose product, either phenology and productivity or next click, please. Anna-Katrina. You can also choose high resolution snow and ice monitoring product, and within that you have data access tab. And next click, please. And to access the data, you may run Wikio Harmonized Data Access Jupyter Notebook, something that Haley was already talking about, so I will not go into details. Right now, I would like to introduce you to land available products and show you a few examples. Next slide, please. The first product is a high-resolution vegetation phenology and productivity, the abbreviation HRVP that I will use for the purpose of this presentation. So what is phenology and productivity? You can see in this blue box, but in the other words, phenology is vegetation, seasonality, and activity, and productivity is estimation from measured activity. And on the right bottom, there is a simple illustration that shows phenology activity when it goes from a low level in winter months and then increases throughout spring and reaches its top within early summer, and then again drops to autumn and winter season to low level phenology activity. The GIF below is a snapshot with rolling days of seasonal trajectories, images of agricultural fields with PPI. This is Plant Phenology Index for efficient monitoring of vegetation phenology. So you can see that this PPI goes actually from low levels, blue colors in winter months, to high levels, red colors in summer months. So now I'd like to just briefly talk about use cases. Yes, thank you. Something that can be, no, the previous slide still, sorry. Yeah, just briefly mention what the data, HRVP data can be used for. We are using it, and it can be used for different purposes. For instance, for carbon sequestration, so measure carbon uptake and stored in vegetation, climate impact, such as fire, droughts, frost levels, crop type, crop rotation, different agriculture practices like cover crop, fallow land, urban ecosystems, and also for monitoring grass mowing events like cutting, grazing, and removing plant material. So all of these use cases are relevant for many of our major policy topics. You can see them in the box like European Green Deal or, for instance, LULUCF. The timeline can be seen at the bottom, and it shows that there's continuous monitoring with time series available from 2017 onwards. Next slide, please. And just to get a quick feel for the products and its components. And as you can see, we have three major sections in HRVP production. We have vegetation indices, derived daily from Sentinel-2 satellites. Among vegetation indices, we can find already mentioned PPI or NDVI that can be used to estimate the density of green on area of land. And this GIF presents daily image acquisition. Then we have also seasonal trajectories. They are derived from a time series function fitting PPI. There are filter images with 10 days time step. And finally, we have phenology and production parameters that are derived yearly for 2 growing seasons. And among them, we have different parameters, for instance, start of the growing season, end of the growing season, length of the season, amplitude, productivity. Here on the picture, you can see start of the growing season. In the regions where you can see it's blue, it's actually early start of the growing season, and red, yellow, it's late start of the growing season. Next slide, please. And then another product from our portfolio, it's snow and ice product, and it describes the snow properties on land and ice occurrences on the hydrographic network. Most of snow and ice data is disseminated in NRT, near real time. This means that it is made available within 6 to 12 hours of satellite observation. The dataset is generated over the entire EA38+ UK, same as HRVP data. And data, as you can see on the timeline below, is analyzed from 2016, actually September 2016 onwards. Also, a few words about use cases. These are critical parameters to a wide range of applications relevant for many areas of forecasting in the field of weather, climate, hydrology, water management, also for assessing natural hazards, floods, avalanches, river ice jams. The study of snow and ice has also significant socioeconomic interest, such as winter tourism, agriculture and forestry, hydroelectric power generation, and the policy context is also connected to water supply, climate change adaptation, or disaster risk reduction. And the GIF on the right bottom shows illustration of melting Alps throughout April to July 2018, and you can actually notice how dry snow, colored in blue, transforms to wet snow, purple color, and then throughout July actually disappears, so eventually melts off, and there is no color. Next slide, please. And just a brief overview of our snow and ice products portfolio. We have 5 snow products, among them 2 snow cover products. There is fractional snow cover, which provides the snow fraction on the top of the canopy and on the ground. And here you can actually see the example of fractional snow cover in percentage, where 0 is black color and 100% is white color in Madrid. And you can see how it has been changing in January 2021. And then another product is daily cumulative gap filled fractional snow cover that completes fractional snow cover product. Then we have 2 snow state conditions products, wet, dry snow, that differentiates between wet and dry snow. And here you can actually see the example of high resolution information on snow states from June 2021. A picture was taken over the mountains. And another snow state condition product is SAR wet snow product that provides information on the wet snow extent in high mountains. And the 5th snow product is persistent snow area product. This one is produced on a yearly basis and provides the extent of persistent snow cover. So the area where the snow is present throughout the whole year. And here you can actually see persistent snow area for year 2021 over the mountains in the region close in between Italy, Austria and Switzerland. Next slide, please. And then we have two ice products defined on the hydrographic network. First product is river and lake ice extent product. This one provides information about the ice cover. And here you can see the example of river and lake ice extent product based on Sentinel-2 and present ice cover on the Daugava River in Latvia from February 2021. The other product is aggregated river and lake ice extent. This one provides information about the ice extent. This product is generated quarterly and provides the percent coverage of snow-covered or snow-free ice on lakes on 10-kilometer river sections. And this example is from Vistula River from February 2021. You have the attribute table for one river section outlined in yellow, and the red outline on the picture is derived from EU Hydro database. So far, these are all our land products hosted on WikiODS that can be accessed through Jupyter Notebook, but more is coming soon. Thank you.
Thank you very much, Joanna, for this explanation. We'll go from land to the marine environment with Fabrice Messal from Mercator. So Fabrice, the floor is yours.
Yes, thank you. So I'm Fabrice Messal. I'm a user experience and capacity development manager at Mercator Ocean International, which implements the Copernicus Marine Service. In capacity building and training activities, we use a lot of Jupyter notebooks. This is a very powerful tool to share expertise and tricks and tips. So I'm very much looking forward to seeing what you will create in this competition. So let's start with this quick overview of the marine datasets of the Wikio platform. So if you dive in the Wikio catalog, you will discover a wide range of marine data to know the past, the present, and the future state of the physical ocean, what we call the blue ocean, with variables like temperature, salinity, currents, and waves. The biogeochemical ocean, the green ocean with the concentration of chlorophyll, the nutrients, etc. And the sea ice variables, the white ocean with sea ice concentrations, sea ice thickness, and extents. Next slide, please. So you have different source of products of catalog in the Wikio catalog. I would start with the Copernicus Marine Service portfolio. All the products from the Copernicus Marine Service portfolio are available on Wikio. These products can be derived from different data sources, 3D models or in situ data or satellite data observations. The data may be complementary in terms of spatial or temporal resolution. It depends on the subject you are interested in. They cover a wide temporal coverage with data over the 25 years in the past, near real-time and real-time data, and also forecast thanks to the models. They are available for the global ocean and for each European regional seas. Next slide, please. So some example of the Copernicus Marine Service portfolio with, for example, the Reanalysis product, which represents a long time series data over the 25 years in the past. It can be used to understand phenomena or study past situations. You can also have access to analysis and forecast for physics, wave, or biology. This kind of product which provide up to 10-day forecast, and it can be very useful to imagine future scenario. And L3 and L4 satellite products are also available on this catalog for high resolution needs. Next slide, please. The marine data are not limited to the Copernicus Marine Service catalog. You have also access to the Sentinel-3 marine catalog with data from the level 1 and level 2 data, with information on the altimetry, the ocean color, the sea surface temperature, the atmospheric composition. And satellite observations offer high spatial resolution products. And these kind of products can be very useful, again, to visualize rapid or very located changes of the environment. Next slide, please. Now I will introduce you 3 use cases to give you an overview of how the people can use the data. So the first use case is an application for marine renewable energy developed by OpenOcean. It's a platform to exploit the data from Wikio and visualize informations used, for example, site characterization for marine renewable energy to assess the potential impact, but also the potential of energy of the sites, to build infrastructure for the safety of the sea workers, to be able to know the state of the ocean, and during the exploitation for operational purpose, safety, environmental status which can be required by the European Union or the national authorities. The Jupyter Notebook can be used to create new ways to represent the data in this kind of Metocean application and give access to a new point of view and informations. Next slide, please. So the second use case is an application for aquaculture. Jupyter has developed a tool with high-resolution data for aquaculture industry. They facilitate the use of the data for their customers. They turn data into information. Again, this kind of application can be used for site characterization to assess the environmental status and condition of a location, and to assess the impact of the activity on the area, to building the infrastructure, again, for the safety of the sea worker and the exploitation. And in this kind of topic, the Jupyter Notebook should demonstrate the capacity of Wikio platform to mix different kind of data, from atmospheric data or to marine data, from satellite data, in situ data with model data, even external data like users data. Next slide, please. And finally, the third use case about environment monitoring. It's a tool to monitor and predict algal bloom and forecast the drift of these algae. This is an example of the use of artificial intelligence to enable authorities to take advantages of all available data and prepare their response to this threat. Imagine Wikio has a huge amount of data and what you can do with it using machine learning or other artificial intelligence technologies to create predictions, for example. To conclude, I would like to add that Jupyter Notebooks are a very powerful tool for training and share expertise and experience. From my point of view, the most important thing is to be able to tell a story, to put yourself in the shoes of a user, and to propose an innovative point of view on the data and the information you can create with it. So let your creativity speak and be inspiring and a good competition tool. Thank you.
Thank you very much, Fabrice, for the encouraging words and the explanation on the Copernicus Marine Environment Monitoring Service. We'll then go to the Copernicus Atmosphere Monitoring Service and the Copernicus Climate Change Service with a presentation by Chris Stewart from ESMWF. Chris?
Yes, thank you very much, Anna-Katrine. So a very warm welcome to everyone. So my name is Chris Stewart and I work at ECMWF. And I'm going to present today the Copernicus Climate Change Service and the Copernicus Atmosphere Monitoring Service. And I'm going to do these presentations kind of together because they share some common elements. But I'll begin with a few slides about the Copernicus Climate Change Service, so C3S for short. So this service provides authoritative information about the past, present, and future climate. And as you can see from this very cluttered and messy slide, it has evolved in the last few years in line with an increasing momentum, a global momentum, to develop a climate resilient future. And ever more, it's important for stakeholders in many different sectors to adapt to climate change, mitigate climate change. And we have developed many data and tools and services to help these different stakeholders. And what I'm going to present in the next few slides are some of these data. So next slide, please. Can we please go to the, great, perfect. So when we talk about climate data, we really focus here on different climate variables. And as you can see, there are very many of them. So we call these essential climate variables. And these characterize the climate of the entire Earth system, including the atmosphere, land, ocean, cryosphere. And these variables can be measured by satellite, by in-situ data, in various different ways. And we provide data for many of these variables. Next slide, please. And we provide data from these variables for the present, for the past, and the future. And these exist in satellite data, in situ data sets, also in rescued data. So rescued data means, old data that may be recorded on paper charts, and we have, and they have been digitized. So these are available from the Copernicus Climate Change Service. But then an essential component that we add is the modeling part. So what we do is we provide models and we project this data into the future. We either through predictions, through forecasts, or through projections into the longer term. And then we also use these models to fill in the gaps in space and time in the past. So where the observations may be a bit sparse, we can fill in these gaps and we can provide consistent data sets that lend themselves very well to the kind of Jupyter Notebook competition such as this, where you can work with gridded data sets and you can work with labeled data, very good also for machine learning. And we provide all this data, in fact, petabytes of this data. And this is freely available to anyone worldwide. So I'm just going to speak a little bit about the different types of data. Next slide, please. So one of the key data sets we provide are what we call climate reanalysis. So a climate reanalysis is exactly what I just mentioned. When you take the observations and you use models, use forecast models, the state-of-the-art forecast model to interpolate between those observations in space and also over time in order to derive a decades-long data set, completely filling in all the gaps and with a consistent record. So using the same model over a long time period. So you don't have, different data well, you have different observations, but they've been assimilated all together to produce the best possible data set characterizing the climate from the past. And you see this rather complicated figure at the top. So the scale on the y-axis, that's pressure levels. So we do this for different levels of the atmosphere. So this is for one particular variable, which is temperature. And if you look at the x-axis, so this is time, and it goes from 1950 pretty much to the present. And this is one, global temperature. So one measurement for the whole world. It's been averaged, but we provide gridded data for the whole world. And we see it for the different layers of the atmosphere and over time. This is one example of a plot that you can produce with the data that we have, but you can do many other things as well. So in the bottom, you see an anomaly. So what we've done here is we've taken the climatology, the average of the whole climate for let's say a 30-year period, and then we've subtracted that from a measurement from a particular time, and then you're left with an anomaly with respect to the climatology, and you can see how the anomaly varies over time. And you can also look at time series. So that's a figure on the bottom right. Next slide, please. So in addition to reanalysis, so data from the past, we also provide model data for the future. And this exists as seasonal forecasts. So a seasonal forecast will not tell you if it's going to rain on a particular day 3 months from now. What it will tell you is what is the likelihood, is it more likely to be a rainy period or less likely to be a rainy period? And this relies on initial conditions, so it's a proper kind of forecast, but it doesn't give you it doesn't tell you what the weather will be. We have other products for that. The Copernicus Atmosphere Monitoring Service does provide a forecast over the next few days, and I'll come to that in a minute. Another thing that C3S provides is our projections. So these are not based on initial conditions. These are more focusing on boundary conditions, and they'll project what a particular variable will look like up until the end of the century, or even in some cases beyond, according to different scenarios, according to different behaviors that we can hypothesize for the future. Next slide, please. So this is actually critical for climate adaptation and for decision makers to know what could happen in the future. So what I've showed you so far are really the kind of core data sets. So we call them core data sets. So these are the ECVs, the essential climate variables, from the past, from satellite measurements, from reanalysis, from seasonal forecasts and climate projections. But another thing we've done is we've already combined these into kind of high-level information products. So we've combined into climate indices, combining one or more ECVs to give you things like thermal comfort index, wind chill, these kind of indices, and also these data sets have also been made available in the form of applications. So applications are web-based applications where you can very easily experiment with different parameters and visualize results without having to actually get your hands on the raw data and do all the processing yourself. Although in this case, for the Jupyter Notebook competition, I imagine you have some familiarity with coding and you will want to get your hands on the data. But at least you can see some examples here, and you can even see the source code. Next slide, please. So now I will just speak a little bit about the Copernicus Atmosphere Monitoring Service. So this is similar to the Copernicus Climate Change Service in that we provide reanalysis data from the past, data from the future, but here we're focusing on the atmosphere. So CAMS, which is the acronym for the Copernicus Atmosphere Monitoring Service, provides information data from Earth observation and info products on global atmospheric composition, the ozone layer, air quality, also emissions and surface fluxes of certain pollutants, and greenhouse gases, also solar radiation and climate radiative forcing. So this is all available for free from CAMS. And I'm now just going to show, what I'm going to show you in the next few slides. In 7 minutes, I can't really explain all of the different data that we provide, but I can give you a flavor. So next slide, please. So just here are some example charts from some of those data sets that CAMS provides. So here we see, for example, aerosol optical depth at 550 nanometers. We also provide organic matter aerosol depth, dust aerosol depth, so a lot of other variables. Here you can also see a chart for total column carbon monoxide, surface PM2.5 concentration, and surface nitrogen dioxide. So these charts are actually available as charts on the website of CAMS, but you can also get the data and you can produce similar charts yourself, or combine the data to produce indices or to do other things. Next slide, please. So here's just some example of products for the Antarctic ozone hole. So we provide data for stratospheric ozone, but also tropospheric ozone. So many different data sets available also for ozone. Next slide, please. So in addition, we also provide information on emissions and surface fluxes. So these include, for example, emissions inventories, which are available. And also on the right-hand side, you see an example of fire radiated power. This is from the GFAS, the Global Fire Assimilation System, where we look at active fires, the intensity and location of active fires, and estimate the emissions from these fires. So I encourage you to go to the CAMS website and look at these different categories of products. Next slide, please. Okay, so what I'd like in the last few minutes that I have, I'd like to just talk about the data from these services. Now, you have seen from Haley's presentation that this data, a lot of this data is available on Wikio. You can search the catalog. You can get the data from there using the HDA mechanism, the Harmonized Data Access Mechanism. That's one way to get the data. We also have more information on the CAMS and C3S website. So if you want to understand more about how these products were produced, you want to see the full documentation, you want to see also the quality control, then that's all available on the websites and also through these data stores that the screenshots of which you can see here. So we really recommend you to explore the data, have a look at it, read the documentation, look at some example charts, but then, really get your hands on the raw data. Next slide, please. And as I've already mentioned, this data lends itself very well to the kind of competition that you're taking part in now. So most of the data are in NetCDF format, or in some cases in GRIB format, but these can be read into X-array objects. They can be, most of them are most of them are gridded, so they're very easy to work with, especially for machine learning. Where you want to have an easy to use data set, you want to have you want to have a seamless kind of data for a long time period, and also labeled data. So this is very good for machine learning, but also for many other techniques. And we have some good examples of notebooks that you can use as a template for your work. Next slide, please. And then finally, if you need more support, if you want more help, or you want to find some more information about these products, or you have any questions at all, then this slide shows you how you can get help. So first of all, we have we have this virtual assistant. It's called a knowledge duck. It's a robot you can ask questions to. If the robot doesn't have the answer, if you have a slightly more sophisticated question, then you can go to the Copernicus knowledge base. And this contains very good documentation, very comprehensive documentation. If you don't find the answer there, you can go to the forum. There's quite an active forum where you can see if someone else has already raised your question, or you can put the question to the forum. And then finally, if none of those channels can answer your question, then you can go to the support portal and you can submit a ticket, and you can get help from a human being who can give you the answer. So that, I think that brings me to the end. And again, I wish you very good luck with the competition. And don't forget to contact us if you have any questions. So thanks from me.
Thank you very much, Chris, and thank you to all of the speakers. I believe in the meanwhile, all of the questions seem to have been answered in the Q&A. I see some new questions popping up. Should the submitted notebooks for the competition be relatively short and focus on a specific concrete task or question? Or can they also be larger use cases with several levels of analysis? Neil, maybe I can let you answer that.
Yeah, I think it would be fine if the notebooks are more detailed too. I mean, I think we want things that people can easily follow. That's the key thing, and that they're innovative with new ideas. If you can do that in a shorter way, that's fine. But if you need more space to really kind of tell a good story, then I think that's okay as well. I don't know if Hayley has anything to add on that, or.
Yeah, I think you're right, Neil. I think this is fine. I mean, tell the story you need to tell, right? I mean, I wouldn't make your notebook too heavy so that it, you know, won't run easily, or too slow for people. Sometimes that can be a problem with, especially with Jupyter. It does have memory limitations, so just be aware of that as you're developing it. You could also submit it into multiple parts then if that was a problem. But yeah, we're interested in whatever stories you have to tell, really. I don't think you have to be too limited.
Great, thank you. At the moment, I don't see any other new questions, and we also we're also at 5 p.m. here in Central European summertime. But if there are any further questions, you can always also reach us at notebook@wikio.eu for any competition-related questions. Then there's support at wikio.eu for any kind of questions if you're struggling with the Jupyter Lab or the Wikio interface in any way. And as Chris shown, for the various services, there are also help desks. So please don't hesitate to ask for help. And we really look forward to your notebooks. Neil, do you have any last words?
No, well, just good luck to everybody, and we're really looking forward to seeing what you can come up with. I think you can probably tell that by the enthusiasm here that we're really excited, and you've got from now until July 31st to get your notebooks in. So